Hello everyone, welcome back. So this week I'm going to go over how the activities would have been conducted if we were in lab. I hope you guys had time to look over those videos. If you guys are still struggling with the concepts, let me know. I could either do a recording or look for more videos. I did think that this topic of natural selection and evolution is best demonstrated through videos just because you can see the differences in the animals and it's a better visualization. But if you need some more assistance, just let me know and I could find more resources for you guys. Okay, so I'm just going to go over how these activities would have been conducted if we were in lab. Okay, so I'm just going to do it this way because the other one's so large. Okay, so really exercise 1 and 2 or activity 1 and 2 are going to build off of each other, but you're going to basically attempt to mimic what happens to birds in nature. So you're going to use bird beaks, and I'll go over what these bird beaks will be to harvest seeds. And your seeds are your food source for these birds. And you will see if you are successful or not. And we're going to essentially apply this concept to natural selection and also to a larger population. So to set up this lab, you are going to need 4 different seeds. So if we were in class, we would go outside at a grassy area. You guys would take pinto beans with you, black beans, green beans, and lima beans. You would take 50 of each beans for a total of 200 seeds. And then you guys would be split into groups of 4. So as you can imagine, these actually have very similar shapes, but you could use 4 totally different seeds or objects. You could use like an M&M, a pasta, like a pasta noodle, a bean, and a grain of rice, or something like that. And you could see how the grain of rice may be more difficult to get because it's tinier compared to like an M&M, which is larger. So some of these will be easier to harvest than others. And the way you will be simulating your bird beak is using a pair of either forks, a pair of spoons, a pair of knives, or forceps, so like these tweezers. And each person will get a different um, beak. So one person will get the pair of forks, and those will be that person's. Like person number 1 will have a pair of forks, and that will be their bird beak. Person number 2 will have a pair of knives, and that will be their bird beak. Person number 3 would have the pair of spoons, and that would be their bird beak. And person number 4 would have the forceps, or these tweezer legs forceps, and that would be their bird beak. And then everyone will have a cup. This will be your bird's stomach. So when you are able to successfully pick your beans or seeds from the floor, you will put your material into this cup as shown here, and that will be your stomach. Okay. So this will be timed, so you have a certain amount of time to, you will have 1 minute, and then you will stop collecting. You will analyze how many beans you were able to collect, and then you will see if you make it on to round 2. So in order to go on to round 2, you have to have consumed more than 200 calories. And then in order to go on to round 3, you would have to consume more than 300 calories. And each seed is associated with a different number of calories. So let me see if I could pull that up down here just so you guys have a bit. So the pinto beans are worth 5 calories, the black beans 10, the green beans 20, and the lima beans are 3 calories. And these are just arbitrary numbers that were assigned. Okay, and you could do this at home. Like I said, you could do it with, for example, Cheerios, with pasta noodles, with grains of rice and beans would be a good start. And you could recruit family members or roommates to use different objects in your house as bird beaks. So someone could get 2 chopsticks or a pair of chopsticks. Someone could get tweezers. Someone can get a clothespin, and someone could get like this paper clip or something. So this kind of shows you step by step what you would do. So in round 1, you would see how many seeds of seed type 1 you got, and then you would count like the number of seeds you collected and how many calories that translates to. So this is walking you step by step. So just if you would like to do this at home, walk through that. I'm going to show you guys on the one that's already completed. So here, for example, you collected in your first round 6 pinto beans. 6 times 5 is 30, so you have 30 calories consumed there. You collected 3 black beans. 3 times 10 is 30, so you have 30 calories consumed there. You collected 1 green pea. Green peas have 20 calories, so you have consumed a total of 20 calories there. And then you collected 18 lima beans. Each lima bean is worth 3 calories, so you would have collected 36 or consumed 36 calories there. So for a total consumed of 116. So did you consume enough calories to survive to round 2? No, you did not. So here's an example, assuming you have survived. So you would have done the same thing. Say you collected 7 pinto beans, that's 7 calories consumed, etc. for the rest of the seed types. And then the total calories consumed are 235. Since that is over 200, you have survived to go on to round 2. So then you would go to round 2 and do the same thing. Okay, so then for activity number 2, it's basically the same. It has a very similar premise. So in activity 1, we examine how successful birds are. So now we have to think that when birds harvest plant seeds, these same rules are going to apply to these plants. So these birds are consuming the seeds from these plants. How do these plants reproduce? They reproduce through their seeds. If the birds prefer one seed type over another and they consume all the seeds for that plant type, it's going to be very difficult for that plant to reproduce since all of its seeds were consumed by the birds and weren't able to go back into the soil and produce more plants. So that's basically what's saying. If a bird prefers certain seeds over other, this impacts the success of plants. The plant community can change in response to selective pressures that birds apply onto plants. So remember that plants experience natural selection just as much as birds do. So here, we started off with 50 seeds for our seed type 1, 2, 3, and 4. And then you write in the second column how many of seed type 1 were eaten, seed type 2, seed type 3, and seed type 4. And then in the following column, you'll write the number of seeds uneaten. So let's go through it over here. And this is just walking you step by step. So if you want to fill it out here, you would just follow these steps, etc. But let's go to one that's already filled out so it's easier to verbalize. So for pinto beans, we start off with 50 pinto beans. How many did we eat? We ate 6 pinto beans. So how many are left over? Well, you do 50 minus 6, which is 44. And then you would do that for all of these because that's completing A, B, and C first is the easiest. So then you would do it for black beans. If we started off with 50 black beans, you ate 3, 47 were uneaten. Started off with 50 green peas, you ate 1, 49 are left over. You started off with 50 lima beans, you ate 18, so you have 32 left over. And then you will see how this, so then you're gonna add up all of these uneaten seeds for a total uneaten seed number, which is referred to as E. So if you add up 44, 47, 49, and 32 together, you're gonna get 172. and then you have to determine the proportion of uneaten seeds. So here you would do 44 divided by 172, that's 0.2558, so roughly 25%. And then you would do 47 divided by 172, that's roughly 27%. 49 divided by 172, roughly 28%. And 32 divided by 172 is roughly 18%. So in your next round, you're going to be able to start off with 51 pinto beans, 55 black beans, 57 green peas, and 37 lima beans. So as you can tell from this data, lima beans were preferred. So in the next round, there's going to be less of those available. On the other hand, green peas were not preferred. I mean, you only ate one green pea. So there's going to be more of those left over for the next round or the next season. So this is just walking you through activity 2. And then you would do the same thing. You would go do activity 2 and then determine your data for activity 2. Okay, so then, oh, there was actually a graph I wanted to show you, so I'm going to pause this right quick. Let me go ahead and pull up that graph very quickly. Okay. Let's see. Okay, so I wanted to give you guys a visualization of this data here. So like we said, green peas were not preferred, so there's going to be more available in round 2, whereas lima beans were preferred. A lot of them were consumed, so there's going to be less lima beans available in round 2. So I wanted to show you guys a visualization of that. And that is shown here. So if you look at this graph in the beginning in round 1, we are starting with, remember, the same amount of pinto beans, black beans, peas, and lima. We're starting off with 50 for each one. When we move on to round 2, what did we see? We saw that lima beans were preferred. So now look, there's a reduction in the number of lima beans available. And then we saw that the green peas were not consumed very much. So as you can see, there's an increase in the availability of green peas. And then when we move on to round 3, you can see that margin for lima beans getting even smaller. So there's even less lima beans available. So the birds who depend on lima beans are going to be affected. And then the birds that depend on black beans and green peas are going to have an advantage because their food source is going to be in abundance. So either this bird's going to have to learn how to feed off of something else, or unfortunately it will, not be able to survive. So this is a good visualization to see how what the birds are eating, what is easier for them to consume depending on their bird beak, will also affect the survival of plants. So it affects the survival of the birds, obviously, but it also affects the survival of the plants. So activity 3, I posted a video for you guys to watch. But there's also in your lab manual a passage to read about activity 3. But essentially, Peter and Rosemary Grant were researchers, and they went to the Galapagos Islands, specifically Daphne Major, to do some investigations on natural selection and Darwin's finches. And Daphne Major is known to have major climate fluctuations. So most years there's steady rain, so there's a regular um, rainfall pattern, but there's extreme years where you will experience extreme drought, and there are also years where you will experience heavy rain, referred to as El Nino. And essentially what they did is in 1973, Peter and Rosemary Grant, they're from the Princeton University, they began their studying Darwin's finches on Daphne Major. They went and catched individual birds living on the island, and they tagged them. And these birds were studied exhaustively, and measurements of body and beak size were made after each year. Well, in 1977, this island, Daphne Major, experienced a drought. And what they saw was that there was they experienced a drought that was less than 1 inch of rainfall during the normal wet season. So it was very dry season, and they saw a decrease in the overall finch population. But they saw that those with the small beaks were hit harder compared to the birds with the large beaks. So so the birds with larger beaks tended to survive better than the birds with the smaller beaks during drought years. And then in 1982, there was another drought. And once again, they saw that the birds with the larger beaks tended to survive better than the birds with the smaller beaks, although there was an overall decrease in bird population. It seemed to hit the small beak birds harder than the large beak birds. And then they saw that during the wet years, small beak birds did very well. So during these El Nino um, heavy rain patterns, they saw that the small beaked birds did very well, surviving and reproducing more than the large beaked birds. And there's a video, like I said, to look at this, but they saw that this had major environmental consequences in their food supply. So for the groundfish, this meant the seeds. So this really builds off of that study we just did in activity 2. So in dry years, they saw that these large seeds tended to survive. So think of like, different plants and food sources can have different seeds. Think of a avocado who has a very large and thick seed. So the plant uses all of its energy to build such a large seed versus something else that has lots of little tiny seeds. So in the dry years, they saw that the large seeds survived. In order to get to consume a large seed, you're going to need to have a larger beak because these seeds are larger and harder to crack. And then they saw in the wet years that these small seeds from grasses and herbs seemed to survive. So as you can imagine, a bird with a small beak can get these small seeds a lot easier. So here's some hypothetical data that they collected. And you want to notice the trends. You want to see when there's larger beaks, when there's a, you want to notice the trends in beak size. So in 1977 to 1981, 1977 to 1981, we see a preference for larger beaks. So what can this suggest about the climate? What can this suggest about the seeds available? And then between 1981 and 1984, you see a decrease in beak size. So what could you predict about the climate changes during that, or the weather patterns during those years? Or what can you predict about the plant resources available during those years? So if plants responded to rainfall by producing larger or smaller seeds, how could this impact birds? So go ahead and complete those questions if you guys have, or go ahead and complete the blue boxes in your lab manual. If you have any questions, please let me know and I'll be happy to help you out. Okay.